Jupiter is the fifth planet from the Sun. Jupiter is a giant gas world and the biggest planet in the solar system, more than twice as massive as all the other planets combined. Its diameter is 86,881 miles. Orbit 11.9 Earth years. Day 9.8 Earth hours. Jupiter is that big you can fit 1,300 Earths into its large scale. Its giant spot can fit 3 Earths in it alone. The giant spot's winds are between 270 miles per hour and 425 miles per hour. Comet Shoemaker Levy-9 was a comet that broke apart in July 1992 and collided with Jupiter in July 1994, providing the first direct observation of an extraterrestrial collision of solar system objects. It was discovered on March 24, 1993, discovered by Carolyn Shoemaker, Eugene Shoemaker and David Levy. Dimensions is 1.8 kilometers. Aside from emitting UV and X-ray light, the northern lights of Jupiter also paints the air in red, green and purple. The planet's strong magnetic field, at times 20,000 times stronger than Earth's. It attracts charged particles not only from solar wind but from those spewed by supervolcano explosions on its moon. Ever since NASA Voyager 1 spacecraft flew past Jupiter in March 1979, scientists have wondered about the origins of Jupiter's lightning. That encounter confirmed the existence of Jovian lightning, which has been theorized for centuries, but when the venerable explorer hurled by the data showed that the lightning associated radio signals didn't match the details of the radio signal produced by lightning here on Earth. In a newspaper published in Nature Today, scientists found NASA Juno mission described the ways in which lightning on Jupiter is actually analogous to Earth's lightning, although in some ways the two types of lightning are polar opposites. No matter what planet you're on, lightning bolts act like radio transmitters, sending out radio waves when they flash across a sky, and said Shannon Brown of NASA Jet Propulsion Laboratory in Pasadena, California, a Juno scientist and lead author of the paper. But until Juno, all the lightning signals recorded by spacecraft Voyagers 1 and 2, Galileo Cassini, were limited to either visual directions or form the kaleidoscope range of the radio spectrum. Despite a search for signals in the megahertz range, many theories were offered up to explain it, but no one theory could ever get traction as the answer. Enter Juno, which has been orbiting Jupiter since July the 4th, 2016. Among its set of highly sensitive instruments is the microwave radiometer instrument MWR, which records emissions from the gas giant across a wide spectrum of frequencies. You may not believe this, but Jupiter actually has rings. Jupiter has its eclipses, but they're not as good as Earth's. Obviously, with Jupiter's 79 moons and the size of Jupiter being so big that no moon can actually totally cover the planet. Jupiter has 79 moons, but the four biggest that actually can make a difference are Ganymede, Callisto, Io, and Europa.